Today in this video lecture, we will see numerical wall on strain energy and impact chapter. Numerical is a mild steel plate is 400 mm long, 200 mm wide and 50 mm thick. It's subjected to gradually tensile load 1200 kN. Calculate proof resilience, modulus of resilience, elongation and take modulus of elasticity as 200 into 10 raised to 3 MPa. So, we will see this numerical thoroughly. See first, this is mild steel of 400 mm long. That means this is this 400 mm and wide is 200 mm. That means this is width and thickness is 50 mm. Something like this. This is 400 mm length. This is 200 mm width and width is denoted as B and thickness is 50 mm. Thickness is denoted as small t. So this is given data, plate and plate dimensions, and acting load is gradually tensile load. For that use red color. This 1200 kilonewton. This is surface of cross-sectional surface of this acting tensile load. So we have to calculate proof resilience, modulus of resilience, elongation, and given data is this E 200 into 10 raised to 3 MPa, and we all know that 1 MPa is 1 Newton per mm square, and we also know that this E is nothing but the modulus of elasticity or Young's modulus, and definition of this modulus of elasticity is the ratio of stress to the corresponding strain is constant, and this ratio is known as modulus of elasticity or Young's modulus. We all know formula of this Young's modulus also. E is equal to stress upon strain, and unit is Newton per mm square or kilonewton per meter square. Now also we all know that proof resilience. What is proof resilience? Proof resilience is the strain energy stored in a body within elastic limit is called strain energy stored in a body within elastic limit is resilience. Within word is in resilience, and strain energy stored in a body up to elastic limit is modulus of resilience. We all see that in our previous video lectures. And elongation, we all know that elongation is denoted as delta L, and elongation is nothing but the change in length upon original length. Strain is known as change in length upon original length, and this elongation is denoted as delta L. So here to find first is proof resilience, and proof resilience is denoted as U max. Second, modulus of resilience. Modulus of resilience is M or modulus of resilience, and third, elongation is delta L. So And for that, Umax, we all know that Umax formula, modulus of resilience, proof resilience formula. Umax is nothing but maximum stress square upon 2 into modulus of elasticity into area into length. So for solving this Umax, first proof resilience, we all need this. We have this E, see in this numerical, we have this E 200 into 10 raised to 3 MPa. We have this area also, area of this cross-sectional area of this plate is 200 multiplied by 50 and length is 400 mm. What we don't know this sigma max, but we know sigma formula. Sigma is equal to load upon area, and in this numerical they have given us load is 1200 kilonewton. See, units are important. Always use unit like in one equation. Use when we use Newton, simultaneously use mm value. When we use kilonewton, simultaneously use meter value. Only one terminology we consider in this. So when I use Newton, then I use area in mm, and when I use only kilonewton, then I use area in meter, because stress unit is Newton per meter square or Newton per mm square or kilonewton per meter square. We don't give this unit like kilonewton per mm square. So that's why I said you this. So I put this 1200 into 10 raised to 3 load in Newton, and simultaneously I put area in mm square. And area is cross sectional. This load 1200 load acts on this cross sectional area, this h portion cross sectional area, b into t, 200 into 50. And solve this mathematically. 1200 multiplied by 10 raised to 3 divided by 200 into 50 is 120. And unit is, if you don't remember unit, see this 1200 into 10 raised to 3 is in Newton, put Newton as it is, divided by this area is in mm square, this, and this is unit Newton per mm square. Second problem statement is modulus of resilience, and modulus of resilience is nothing but the proof resilience divided by volume, and proof resilience is this sigma square 2e into AL divided by volume. That means this AL upon AL cancel, only this term remember, sigma max square divided by 2e, and sigma max square is 120 Newton per mm square, and divided by 2 into modulus of elasticity is 120 into 10 raised to 3 MPa. So, I don't know unit of this modulus of resilience. So, what we will do, we will calculate it. This 120 is in Newton per mm square. This modulus of elasticity is in MPa. MPa, that means 1 MPa is 1 Newton per mm square. And see the stress square of this stress. So this Newton per mm square is not only Newton per mm square. This square comes to this side. So solve Newton square divided by mm raised to 4. This square inside to this, and divided by Newton per mm square. So this mm raised to 4, this mm square get cancelled, and this Newton get cancelled. So remaining terms are Newton per mm square, and this is unit of modulus of resilience. Calculate mathematically 120 divided by 2 into 120 into 10 raised to 3. You will get modulus of resilience. This 120 square 120 square divided by 2 into 120 into 10 raised to 3. That means this is see this modulus of elasticity is 200 into 10 raised to 3. This is not 120 into 10 raised to 3. See this 200 into 10 raised to 3. So 120 square divided by 2 into 200 into 10 raised to 3 is 0.036 Newton per mm square. And third problem statement is elongation. See, if you don't remember elongation formula also, so what we do, we know stress formula, stress is load upon area, and we also know that E formula, E is stress upon strain, and we know stress upon E is change in length upon original length, and from that change in length is change in length upon L into E is nothing but stress, and delta N is equal to stress into L upon E. So solve like this in exam if you don't remember this. So stress is this 120 Newton per mm square. Length is this 400 mm. And E is given data 200 into 10 raised to 3. That means this is 0.24. And unit we all know, unit is mm, but calculate unit. See, this stress is in Newton per mm square. This length is in mm, and this E is also in Newton per mm square. So this Newton per mm square cancel. Remaining unit is mm. So unit is mm. Unit is very important. If you only put 0.024, there is meaningless data. If you don't put unit, data is meaningless. Always put unit. mm is important, 0.024 mm. So this is our numerical. Thank you for watching.